Deep in the heart of the Persian Gulf, on a rocky island off Iran's southern coast, a port complex moves 3 million barrels of crude oil every single day without stopping, without slowing, and without any single above-ground component that cannot be bypassed by an underground alternative. The pipes run below the surface. The storage sits inside carved rock. Every pump station has a twin buried in a parallel tunnel. A beautiful nightmare for petroleum engineers and the planners of every military scenario in the region simultaneously. The challenge: build an oil export terminal so dispersed, so redundant, and so deeply embedded in the island rock that destroying any visible surface element leaves the oil still moving. This is the Karg Island Export Terminal on the Iranian coast, the largest oil export complex in the Middle East. In 2001, the expansion and hardening program began. Over 300 machines were deployed to the island's surface and to the underground excavation front simultaneously. An army of 12,000 workers arrived on supply ferries from the Iranian mainland. What the geological survey of the island bedrock found at depth will define every aspect of the buried infrastructure program. An unexpected layer of fractured limestone at 30 meters, wet with pressurized groundwater, sits directly below the planned level of the main storage caverns. The underground storage program will have to go deeper than the original design showed. Nothing built on the surface is as permanent as what will be carved inside the rock below it. We go underground before we build anything visible on the surface. The surface structures are secondary. The real infrastructure runs through tunnels cut through the island rock, protected by 40 meters of solid limestone above them. We drill from the access shaft at the western end of the island outward in both directions simultaneously. The first blast opens the pilot heading of the main pipeline corridor. The rock comes down in controlled sequences. Loaders move in behind each blast. Trucks carry the broken rock up the access ramp to the surface disposal site. The pipeline corridors are wide enough for maintenance vehicles to drive the full length. Every pipe run in the network has a parallel run in the corridor beside it. If one pipe fails, the operators close its isolation valves and open the bypass. The oil reroutes through the parallel line. The faulty section is isolated, repaired, and returned to service. The flow never stops. The offshore loading buoys sit 3 kilometers from the island shore. Each buoy is anchored to the seafloor by separate anchor chains. The loading hose systems connect tankers to the buoys in operations that take 40 minutes from approach to first oil flow. Loading rates reach 200,000 barrels per hour through a single buoy. 12 buoys operate at the same time during peak export periods. The combined flow from all 12 approaches, 3 million barrels in a single day. The oil arrives at the island through submarine pipelines running from the Iranian mainland across the shallow Gulf floor. Each pipeline runs a different route. A break in one does not reduce the total flow to zero. Repair crews reach the break and seal it while the other lines continue delivering. The redundancy is built for exactly this condition. Weakness is not an option. The underground storage caverns are sealed rock chambers inside the island bedrock. Each chamber holds millions of barrels in direct contact with the surrounding limestone. The rock walls are sealed with a spray-applied lining. The caverns sit below the water table. External groundwater pressure prevents the cavern walls from moving inward. The weight of the oil inside keeps the system in equilibrium. The chambers are invisible from the air. They are undetectable by radar. Drilling into the island is the only method of finding them. The stage is set. The pumps run. The tankers line up at the buoys. Pump stations distribute oil from underground storage to the loading systems through lines that bypass the surface entirely. The pump housings sit inside the tunnel network. Maintenance crews drive electric vehicles through the tunnels on scheduled rounds. A direct strike on a surface building cannot reach a pump station that is inside a rock tunnel 40 meters below the impact point. The maintenance schedule continues regardless of what happens on the surface. The work continues 24/7. The loading arms at the island jetties extend from the jetty face to the tanker manifold. Each arm locks in place to create a sealed flow path between the shore pipeline and the ship's cargo tank. The arms disconnect automatically if a tanker breaks free of its moorings. The disconnection takes 2 seconds. The shore valve seals in the same 2 seconds. No spill. The tanker floats free. The arm resets for the next vessel. The skeleton of the underground system holds. The oil flows upward from cavern to buoy in a path that never sees daylight. Water flooding into the excavation for the deepest cavern cluster stops the program at depth. The inflow rate doubles in 6 hours after the blast that opens the cavern crown. Pumping equipment at the access shaft runs at full capacity and holds the level. Engineers analyze the fracture pattern in the fresh-cut walls. Grouting rigs move in and drill into the walls at tight spacing. Cement is forced into every crack under high pressure. The inflow rate drops over 10 days. The grouting holds. The excavation resumes. We push through the wet zone and reach the dry limestone below it. Cheering. The terminal reached its designed export capacity in the years following the hardening program completion. The construction army packed up from the underground access shafts. The ramps were sealed except for the maintenance entry points. The oil started moving at full capacity on the first operational morning after commissioning. A tanker that had been waiting at anchor offshore loaded to capacity and departed within 6 hours of the system going live. The Iranian government announced new export records in the following months. Karg Island moves 3 million barrels of crude oil every day through a system that is mostly invisible and mostly underground. The tanker captains, who load at the offshore buoys in the dark of early morning, see only the buoy lights on the water and the distant glow of the island. They do not see the tunnels below the seafloor, the caverns below the island, or the pipeline corridors running through 40 meters of limestone. They see the oil flowing into their tanks at 200,000 barrels an hour, a testament to what engineers build when the surface cannot be trusted and the rock below it can. Where missiles once reached the visible pipes, now the oil moves where missiles cannot follow. An engineering marvel inside a Persian Gulf island. If this kind of engineering moves you, subscribe and ring the bell. Drop a comment and tell us where in the world you're watching from right now. The pump stations that move crude oil from the underground storage caverns to the loading buoys offshore run on rotating maintenance cycles. When one pump station goes offline for a scheduled service, the parallel station in the adjacent tunnel takes the full load. The oil flow rate does not decrease while the maintenance is underway. The maintenance crew services the offline station without time pressure. They return it to standby condition before the cycle brings it back online. The offshore buoys receive a continuous flow regardless of which pump stations are active at any given time. The tanker approach procedure at the offshore loading terminal assigns each arriving vessel a buoy number and an approach time. The vessel maneuvers to the designated buoy on its own propulsion. A mooring vessel assists with the final positioning. The loading hose connects to the vessel manifold. The flow begins. Cargo meters on the buoy measure the volume delivered. When the vessel reaches its allotted cargo quantity, the flow stops. The hose disconnects. The vessel departs the buoy. The next vessel in the queue approaches. The buoy is ready within minutes. The island's desalination plant produces fresh water for the resident workforce from seawater drawn from the Gulf. The plant runs continuously. The water storage tanks on the island hold reserve capacity for periods when the plant is under maintenance. The water network supplies the worker accommodation, the industrial cooling systems, the fire suppression systems, and the maintenance workshops. No fresh water arrives from the mainland. The island is self-sufficient in water supply. The electrical generation facility on the island uses multiple generators arranged so that no single failure reduces output below the operational minimum. The generators run on fuel stored in underground tanks. The fuel storage holds enough supply for extended operation without delivery. When fuel levels drop to the replenishment threshold, a supply tanker delivers a fresh consignment. The delivery connects to the underground fuel network through shore connections at the island jetty. The generators continue running through the delivery operation without interruption. The marine growth that accumulates on the underwater sections of the loading buoy mooring chains reduces the effective diameter of the chain links over time. Dive inspection crews descend to the seafloor anchors on a scheduled program to measure chain condition and clear excessive growth from critical surfaces. The dive program runs year-round. Chain sections, showing where, beyond the acceptance limits, are recovered for replacement. New chain sections replace the worn ones. The anchoring system is maintained in continuous compliance with the design specification throughout the life of the terminal. The offshore mooring system at the Karg Island terminal uses a single-point mooring configuration for the largest tankers. The tanker connects to the mooring buoy at its bow. The ship weather vanes around the buoy as wind and current direction changes. This keeps the vessel aligned with the prevailing forces at all times, reducing the mooring loads on the system. The loading hose connects from the buoy to the tanker manifold amidships. The hose is long enough to accommodate the full range positions the tanker assumes while weather vaning. Hose integrity inspections run on every connection and disconnection cycle. A hose showing where at its bend points is replaced before it reaches the failure threshold. The island cargo dispatch record shows 3 million barrels of crude oil loading every day across the full operational year. Storm closures reduce the loading rate during periods of heavy seas that prevent tanker approach to the buoys. The storm closure frequency has averaged 12 days per year over the operational period since the hardening program was completed. On the other 353 days, the terminal operates at full rate. The oil flows without interruption through the buried pipeline network, up through the buoy connection points, and into the cargo tanks of vessels from dozens of different nations. The worker rotation system brings fresh crews to the island every 30 days on supply ferries from the Iranian coast. The departing rotation transfers operational knowledge to the arriving rotation through a formal handover procedure at every post. The handover covers the current status of every active system, any developing maintenance issues, the current vessel schedule, and the status of any ongoing construction or modification works. No information is lost between rotations. The knowledge of the terminal transfers continuously from one rotation to the next. the environmental monitoring program around the terminal records, water quality, seafloor sediment composition, and marine organism density at monitoring stations, distributed around the island at defined distances from the loading infrastructure. The program tracks any changes in the marine environment that correlate with terminal operations. The data is collected on an annual sampling schedule and reviewed against the baseline established before the hardening program began. The marine environment around the island shows no long-term change attributable to terminal operations that falls outside natural variation in the monitoring record. The terminal produces and archives a complete record of every cargo loaded since the hardening program commissioning. The record includes the vessel name, flag, cargo grade, volume delivered, buoy number used, loading duration, and any operational events during the loading. The record runs without gaps. Every cargo is documented. The documentation supports the vessel operators, the cargo buyers, the insurance underwriters, and the Port Authority regulatory requirements. The terminal is a commercial facility operating under commercial obligations in addition to its infrastructure function. The cargo documentation is part of those obligations. The island's rock provides protection that no surface structure can replicate. 40 meters of solid limestone above the underground cavern network absorbs the energy of any conventional weapon that strikes the surface before the shockwave reaches the installations below. The surface structures that are visible, the jetties, the loading arms, the process buildings, are the components that can be damaged and rebuilt. The rock above the underground network does not change. The oil storage inside the rock does not stop because something on the surface is damaged. The pumps in the tunnel network continue running. The oil continues flowing to the offshore buoys. The tankers continue loading. The terminal operates through events that stop every unburied terminal in the region. The engineering of the Karg Island terminal reflects 40 years of accumulated understanding of what oil export infrastructure must withstand to remain operational through the conditions this region produces. Every buried pipe, every underground pump station, and every rock-carved storage chamber represents an engineering decision made in response to something that happened to a surface component at some earlier point in the terminal's operational history. The terminal is a record of its own vulnerabilities, turned into solutions, built into rock. The terminal has operated without a complete shutdown since the hardening program was completed. Partial shutdowns for scheduled maintenance of individual systems occur on the planned cycle. The aggregate throughput during those partial shutdowns drops by the capacity of the system under maintenance, but does not drop to zero. The oil continues moving through the parallel systems while one system is offline. The throughput record is continuous, 3 million barrels per day, every day, through limestone, through pipeline, through buoy, into tanker. The rock under the island holds the infrastructure that makes it possible. The rock has held it for 40 years.